slide deck. So this is primarily going to be an actual demo showing like from file new building a VR project. I'm going to run through some slides real quick. This is all going to be live coding, and the tech is extremely unreliable. It was working better a couple hours ago in this room, but now it's honestly, it might actually be the people, because it works by looking at physical things, and when people move, that might actually be a problem. I don't know, but we'll figure it out. So please bear with me as we have some various issues. So I'm just going to talk through who I am, just some super basic information on VR. I assume people have a little bit of familiarity, but it's relatively new topic. So I am a C# developer. I'm based out of Tampa. I primarily work in WPF. I've worked in ASP.NET. So this is just a hobby for me. But I've made some various VR things. Certified in 3, 5, and 4. As you can tell, that's quite a while ago. Let's see. So there's basically two major designations. Well, there's kind of 4 designations of VR. There's called 3 degree of freedom and 6 degree of freedom. 3 degree of freedom is you have 3 axes, which means you can look down, you can look left, you can look right, and you can rotate. So that means that there's no translation. You can't walk into a space and have it notice that. So if you used a Gear VR or a Cardboard or any of the kind of the phone-based ones, those are 3 degree of freedom, which means, you know, it's usually best if you sit in a chair because you can rotate, but you can't really walk forward and back. So then there's 6 degrees of freedom, which is like the Oculus Rift and the Vive, and this Windows mixed reality headset where it can tell that I'm walking forward. It can tell that I walked left, not just that I rotated my head, tilted my head, but that I can actually move. In the same way, there's also the controllers can be either 3 degree of freedom or 6 degree of freedom. So these are 6 degrees of freedom. So it can tell not only that I turned it down, but that I moved it forward and back. And then there's tethered and standalone. This is obviously tethered by this big cord. Standalones are like the Gear VR and the Cardboard, which are they don't have a tether back to a physical computer. So right now, the untethered VR is primarily 3 degrees of freedom, but in just a couple of months, we'll have 6 degrees of freedom untethered VR, which I'm really looking forward to. So to actually develop, I'm going to be showing Unity 3D. The other major tool is Unreal Engine. I have a slide here. This is, a strong opinion. But right now, I would discourage anything else besides those two for games and apps. WebVR is a completely different thing. Smaller things. But kind of to go back to the slide of who am I? There are no experts in VR. I'm a hobbyist, so I don't do it full time. But even the people who've been doing it full time, we've only had headsets like this for about 3 or 4 years. I've been to some talks, where they actually had, professors who were researching this for like 15 or 20 years, and they used to have these giant, huge setups that cost $100,000, and just everything's changing so much that there aren't a lot of experts. So my opinion is just opinion of a hobbyist. But there's very little development activity. So if you go to look up a question, and if you're looking it up for Unity or Unreal, you're going to find an answer. If you're looking it up for Godot, or if you're looking up like a different engine, there isn't going to be very much information. There isn't going to be very much help out there. Like I said, WebVR is completely different. But anyway, Unity and Unreal are both free with asterisks. Unity is free as long as you're not a commercial enterprise. Unreal Engine is free as long as you don't make too much money. After that, they're both very affordable. Unity is $100 a month, and Unreal is 5%. So to develop effectively, you really need to have one of these headsets. The Rift is oftentimes on sales for $350. You need a relatively powerful computer. This computer here was a gaming laptop I bought for $600 4 years ago. It technically doesn't hit the minimum requirements for what's suggested, but I mean, just if you look on Slick Deals, you can find a pretty good desktop for like $500-600. Basically, any gaming PC should be able to do VR pretty well. Okay, so we're going to be using Unity 2017, and then we're going to just build from there. So let me go ahead and just start from scratch. Oh yeah. That's going to be a problem. Sorry, 1 second. No, disconnect. The funny thing is I don't actually really need the internet. I just need it to have enough internet to know that it has internet. So. Well, that was close. I didn't actually have the power plugged in. This laptop dies in about 30 minutes. Okay, so this is Unity. I don't know if any of you've seen it, but it's a pretty generic game engine. So, like I said, this is going to be like a file new example, just completely from scratch. This tool is completely free. I'm going to be using Visual Studio. I think the version of Visual Studio I have is actually the Community Edition, so it's actually free. Everything we see here is just completely built in and free. Okay. So this is Steam VR. This is made by Valve, and this is just going to help us basically get the camera and the controllers. We're actually going to hardly use anything from it, but it's a real simple way to get up and started. And when you make something using this, it will actually work on the Windows Mixed Reality, the Rift, and the Vive all in the same way, which is really nice. Okay, so to actually just get started, we're just going to replace our main camera with Steam VR's camera rig. I'm going to save the scene real quick. Okay, so let's just double check that this actually works. Let's just maximize on play. Come on. Nope. Nope, it's not copy. Sorry. Ah, but it's showing that it's tilted. Yeah. There's something wrong. Sorry, I said this is pretty unreliable tech, and this is just par for the course.
What part of it is unreliable? The hardware, the software, or?
It's the software.
Like Unity or?
It's the connection between all this, because so I'm using SteamVR with the beta for Windows Mixed Reality, and Unity's plugging into it, and they just kind of lose sync with each other. Like they're not sure which one's supposed to. Okay, yeah, now it's working. That's it. Okay, so let me see. Let's see the controller. Yeah, okay. All right. So now let's go ahead and just make a nice, simple little game. Let's see how it goes. Okay. Good. We're halfway there. Okay, so let's see what you guys can see. Okay, so you guys can see, and if the text or anything is too small, just let me know. So I just brought in a cube. Unity units are all in meters, so So it was 1 meter by 1 meter by 1 meter. That's a lot bigger than I want, so I'm just scaling it down to a 1/10 of a meter. So I'm going to go ahead and make this cube into a prefab, and the way you do that, oops, I messed up. Okay, so the way that happens, and I really doubt you can see, but this is now blue. It went from black to blue, and that means it's a prefab. This camera rig also here is blue, so you probably can't see it. So prefabs are something that, so this light, this directional light, effectively only exists in this Unity scene, but the camera rig exists somewhere else, and then you can instantiate multiples of them. So I'm making this cube. This cube's going to be a thing we're going to punch. So right now, so it's prefab. Okay, so then let's just go ahead and spawn a bunch of these. So to spawn a bunch of them, I'm going to go ahead and make a cube spawner. Now, I'm just calling it a cube spawner, but it's not. There is no such thing. So I just made an empty object. And an empty object is, so everything in Unity has what they call a transform. And the easy way to think of a transform is it's a location, rotation, and scaling. Now as it happens, we don't care where it is. So the fact that this cube spawner has a location and like a scale doesn't matter, but that's just how everything in Unity is. Everything in Unity physically exists. Well, physically is a little bit much, but it exists in a place in the scene. Okay. Okay. So when you start up, when you make a new class, it puts these things in here by default. As it happens, you can actually change this template to not include these or to include different things. So for our spawner, we're not going to actually care about what happens when it starts, and we're actually not even going to use update. So update occurs once a frame. Now, VR in most of the modern tethered headsets is at 90 frames per second. 90 frames per second is a lot. Most video game consoles run at 30 frames per second. Some games run at 60. 90 is a lot. So you really don't want to do something 90 times a second, because in Unity, if anything takes too long, you'll lose a frame. So you need to be really careful with anything you do once a frame. So in general, in any of these Unity games, or any of these VR games that I've made, I try to not use update at all. Instead, we've got a different thing called fixed update. And fixed update occurs at a fixed time period. Now, as it happens, you can actually decide. You can actually change that speed, but in this case, we're not going to. But sometimes you want it to be faster. So the fixed update is also how often. Actually, I'm not sure it's a fixed update, but they have a similar thing for physics calculations. So you don't want your physics to depend upon the frame rate. Like, if a ball falls from, if something falls off a building, it doesn't matter how fast the world is running in terms of frame rate, it still falls the same way. So in the same way in your game, physics happens separately from how often you update the screen. So in fixed update, So what we're going to do is we're going to say once every 9 fixed updates. Sorry, another guy. So what I did earlier where I have time equals, is this big enough? Can everyone see it? Okay. So where I do time equals, plus equals time dot fixed delta time, that means every one of these fixed updates, so I think it's about 30 times per second. Every one of these 30 times per second add on a 30th of a second. So basically we're just keeping track of the time. And we're saying if our time is greater than the time between, if it's time for a new spawn, then let's go ahead and set the time back to 0. So we're going to make a new game object. So our game object is going, so to make a new game object, you have to decide what game object you're going to make. You have to put it into a place, and you have to put it into a rotation. So now, so what I'm going to do is I'm going to make them appear at, and remember, all these units are in meters. So what we're going to say is we're going to say between, we're going to say make a new one of these cubes at, harder than I thought, so type and talk. To make, we're going to make it between 1 to the left, 1 to the right. Make it between 3/4 of a meter to 1.75 meter, and we're going to have it only appear from like 1 to 1.5 meters ahead of 0. So 0 should be here, but we'll see what happens. And I also have to give it, I also have to tell it what rotation it's in. Now, to tell it what rotation it's in, I have to make what's called a quaternion. Quaternions are evil. You don't want to mess with them. They're a useful way for determining rotations, and the easiest way to explain them is you can add quaternions together. You can't add normal rotations together, because if something is at, you know, like 270 degrees and you add on 90 to it, is it supposed to flip? Is it supposed to go back to 0? It's supposed to go negative. So don't directly manipulate quaternions. They're very bad, but they're just the way you have to do rotations in Unity. Now, I'm just going to leave that commented out for now. We might come back and do that later. We'll see how much time we have. So right now, this is going to spawn a cube every half a second or so. Now, as it happens, the eagle-eyed of you might have figured out, hey, I'm only checking one every 9 fixed deltas. So that means that there's going to be a minimum amount of time between spawns. So if we actually set this time down to 0, it's still going to be 9. So basically, there's a certain cap on how fast it's going to get. Now, as it happens, I did this yesterday, and when it hits that cap, it's a lot. So we'll see. Hopefully here in about 15 minutes, I'm going to be flailing wildly. Okay, so now we can build that. I just did a Control-Shift-D just to build the code. You don't have to. But by doing that, Unity should actually pick up. So I didn't throw any errors. Yeah, so right here, sorry, this is a little bit small. Not a good way to fix this. So back here, we said public game object. Now, by making these variables public, it exposes them through the editor. So sorry, this thing here is called the editor. So now I've got this 0.5. I could change this number. If I wanted to make it bigger, if I wanted to make it smaller, I could do it right here. And I need to set this game object. So if I just hit play right now, So we were hoping to spawn cubes. We made a function called spawn, cube spawner, but it's not going to work. And let me do it again where it doesn't throw errors. Now down in here, we're starting to throw these unreferenced exceptions. And it's an unreferenced exception because this is null. This is null because we haven't assigned it. So let's go ahead and assign it real quick. Assign this to cube. And then we're not throwing any errors. And I don't know how well you can see. Can you see where the cube spawned? Okay, so I've got all these various cubes spawning. Now, that's not a very fun game. So, okay, let's go ahead and make them move. Oh, before we go on, now this isn't super critical necessarily yet, but I'm just going to do it now. I'm going to make these things kill themselves. And in part of the reason I'm showing this is just kind of show you, in Unity you can do all these things in C#. Like it's just coding. If you're used to coding .NET, the only thing you have to do is you have to figure out which of the new keywords you're going to use. So now the reason I was concerned about this is you really don't want to have too many. You don't want to have too many objects because all of these objects are going to be kind of looked at by the game engine every frame. And if you just have too many, game objects, and they're all moving, and it just has to do too much work, and you need to be really careful when you're in VR to not do too much, because if you do too much, you're going to start dropping frames. And dropping frames just means, like you're playing a video game and all of a sudden it's not as common as it used to be, like back in the N64 days or something, but it just doesn't, it's not running as well. And it's a lot bigger of a deal in VR because you've got this thing on your head. And you turn your head to the left, and if you drop a frame, the world doesn't turn. So you need to be really careful to keep your performance up. So I'm just gonna do a real quick another one of these. Now in this case I'm gonna do it on a modulo 8. And I'm just doing it on a different number to try to make sure that the least amount of things. Now these are all going to be spawned at different times anyway, but I want the least amount of things possibly to hit at the same time period. And it's just kind of a way to hope. Now this is an interesting one. That the first time, if you go into do Unity, and this will be one of the very first things in this. Like I said, I'm a hobbyist, so it comes back and bites me about every 6 months. I forget about it. So GameObject.destroy is just saying, Unity, go ahead and destroy something. If you just say GameObject destroy this, you don't destroy the cube. You destroy the script, kill self at time. So I ran into this, like 3 days ago when I was retrying to do this presentation. It's like, oh, all my cubes are still there. They just are missing the script. So when you say this.GameObject, it goes and gets the cube, not the script that you're running on it. So let's see. Again. I did say 5 seconds. So okay, yep, and it showed up. And that's just a real easy way to figure out where you see this time, where this popped in. I could tell that the code compiled. And now this one's interesting. So I have the cube here. Let me zoom in a little bit. Let me get rid of the gizmos. Yeah. All right, so this cube, 1, 2, Why didn't it die? Yeah. Now, I don't know if I did it in this case, but this is a good point to bring up. Now, if you notice when I hit play, this goes red. That's not standard behavior. It's real quick. It's in preferences. If you actually use Unity, I suggest you do that, or set a color. The reason is if you hit play, and then you're sitting in here, and you okay, okay, and you start moving things around, you start changing things, you start doing some lighting. As soon as you stop play, everything snaps back. And it seems a little bit strange until you realize that that's what the game engine is doing. When you're playing the game and you're running script and you're moving things around, you wouldn't want it to then, when you stopped it, to reset. You wouldn't want every time you played the game for it to be a different game, for it to basically become a different game. So if you end up, so there's little hacks around it, but you can basically just, if you get something in the place you want and you're in play, you just kind of save that information off, you snap back out and you put that information back. Anyway, getting a little off topic. Okay, so let's just make sure you destroy yourself. So then okay on time. Okay, so self-destroying cubes is not that fun. Now, there is a weird behavior that I'm not entirely sure why of, but as soon as the cube destroyed, the spawning stopped. So I think the issue was I set the spawner to use this cube right here instead of actually the prefab cube. So it didn't have anything. So once the cube was gone, it didn't have anything to instantiate, it didn't have anything to copy. So usually, after you kind of get this all taken care of, you actually delete the one in your scene and you just use the one out of the prefabs. That way there's no possibility, but we won't worry about that for now. Hopefully that's fixed. Okay, so a bunch of cubes that spawn and destroy themselves is still not a fun game, so let's make them move. So to make them move, we're going to do it with a physics system. Now, a rigid body just means it's like a solid object. It's rigid. You can push force on it. So I just added a rigid body to it, and if I just leave it as default, it immediately just falls away. And that's because there's gravity. We don't want gravity. So we're going to turn off gravity, and now it shouldn't move, so it doesn't move. Okay, so now we're going to make it move in a direction. So okay. So we're going to go on the cube and we're going to say we want to move towards something. Now, as it happens, since we know we just basically want it to move towards me in negative x, we wouldn't have to do this, but this gives us the ability to change how we want it to move. Cone. It is not happy. Okay, so I don't know why this is happening, but this will just help.
I was going to say, it doesn't look like it intelligence.
It doesn't. And I figured, so you'll notice this Monobehaviour is not highlighted. I don't know why, but just in the last couple weeks I've noticed this, that the issue was it wasn't being included in the project. So it just made the file, so now, okay, come on. can do it. Okay, so now I'm getting IntelliSense again. So it just wasn't going to compile the code for some reason. Anyway. Sorry. So we're just going to add a force to it. Again, if you're adding forces, you need to, in Unity, you need to tell them how you're going to add the force. In this case, we're going to add force in negative z. So yeah, the coordinate system is x to the right, y up, and z forward. So negative z is this way. All right.
So if it's negative z, if it spawns behind you, is it going to go still toward you?
No, it'll keep going farther behind you.
Okay.
And okay, so now, so it's going to want an object. We're just going to make object. I'll target. We're going to put target at negative 30. So it should be back that way. We'll see. We're going to make a cube go towards the target. Okay, and now the cube is going towards the target. Now, the reason none of the other cubes did is I didn't apply the changes from this instance of the cube back to the prefab. I just clicked the apply button, and now all of them should start shooting off and all that. Yep, so now they're all flying. Okay. So now we've got moving, self-destroying, spawning cubes. That's still not much of a game. So let's go ahead and just add some UI just to show you what your score is and to keep track of score and set up a thing so that if you touch them with the controller, we'll go ahead and just count the score. So, okay, so we're going to add text. Now, I don't know if you can see there, you see it says text. So this text is actually on the camera. In VR things, in VR applications, you don't want text on the camera because when you turn your head, it moves away from you. So if you put the text in the bottom left-hand corner, on a TV, it's down in the bottom left corner, you can look at it. If you put it in the bottom left-hand corner of VR, if you turn your head, it just keeps running away from you. So usually they say you want to physicalize the UI, which means you want to put it out in physical space. So we're going to change this. So the canvas is how the UI is rendered. So we're going to move it from